Ibariki Tanzania, dumisha uhuru na umoja wake kwa waume na watoto. Mungu ibariki Tanzania na watu wake. Ibariki Tanzania, ibariki Tanzania, tubariki watoto wa Tanzania.
Would you like to learn, understand, enjoy, and apply the beauty of chemistry for the Form 3? Do you have vision that need the knowledge of chemistry in order for you to achieve it? Or have you ever think how can you apply the knowledge, wisdom, and understanding of chemistry to solve real-life problems? So within the few minutes ahead, I will try my level best to answer some of those of the questions that you have in your mind, including the one that I've mentioned and even the one that I've never or have not mentioned. How are you, everybody who is watching this program? I'm very happy to have you international viewers, and I'm very happy to have you national viewers, and I'm very happy to have you my family viewers. This is Olenjolai from Tanzania. My name is Olenjolai Moko Tayelo Singo. Simply just call me Olenjolai. I am a Tanzanian, and this is our national flag. I would like to welcome you into this fantastic program, which is actually we are continuing because we have already begun, and today is just the continuations of what we have already started. So whether you have questions or you have been oppressed because of the way that you've been learning chemistry, you've given up, I want to tell you that don't give up, because there is a hope in Tanzania Online Ordinary Secondary School in square bracket Olenjolai. So I thank God by His own grace, He has given me, or He has built His gift of chemistry in me. I love so much chemistry. And I thank God also by His own grace and love, He built His gift of teaching in me. So in this program, I will be studying as a chemistry teacher in national and the international level. So whether you're a national student or international students, you're warmly welcome. Whether you're national or international parents that have been looking material in order to help your children who are in this level or who are even the next levels, I would like to ask you that to stay tuned. Within a moment, you will receive good news about the beauty of chemistry and the beauty of science. Okay? So I would like to take this opportunity to welcome all our national and international viewers into our Tanzania Online Ordinary Secondary School in square bracket Olenjolai. Simultaneously, I would like to take this opportunity to welcome you into one of our official YouTube channel that called Tanzania Online O-Level Secondary School in square bracket Olenjolai. What are we doing in To'oso? Because the abbreviations of Tanzania Online Ordinary Secondary School in square bracket Olenjolai is To'oso. We are here with vision because the Bible says in the book of Proverbs, chapter 19, verse 18, where there is no vision, people perish. So we have the picture of where are we going, and even sometimes the picture is bigger and bigger and bigger. It will be generational picture after generations after generations after generation. So this is an assignment that we have. We have an assignment to teach and train our ordinary secondary students on how to extract knowledge, understanding, and wisdom, and combine it. Means that to extract knowledge, understanding, and wisdom from the classroom instructions, for example, in chemistry, and combine it with knowledge, understanding, and wisdom that you are going to teach them to extract it from the Word of God written in the Holy Bible in order to solve small-scale, real-life problems that need the knowledge of science or basically mathematics. So in Tanzania Online Ordinary Secondary School in square bracket Olenjolai, we are teaching you at this moment 12 subjects. So what does it mean about 12 subjects? So we are teaching specifically 3 subjects for the 4 classes. So 3 times 4 make 12. So we are here to teach you chemistry, Form 1, Form 2, Form 3, Form 4. We are here to teach you physics, Form 1, Form 2, Form 3, Form 4. We are here to teach you basic mathematics, Form 1, Form 2, Form 3, Form 4. And we are teaching you in extraordinary and exceptional way and in a very simplified language that every passionate students in chemistry, physics, and basic mathematics can take this material and find that they are very helpful for him or her to achieve his own vision. So you have so many informations. This is mindset build-up. We'll be taking number of the years to achieve it, or it may be it might be a journey of session to session, topic to topic, subject to subject. But the one thing that you have to expect in our online school is to be able to transform, or it means that to draw out the classroom instructions to solve small-scale real-life problems. So I know that among you are my registered students, and among you also we have non-registered students, new students. So new students, you're only welcome. You're only welcome into our program. So before even just navigate to you, I would like also to take this opportunity to welcome into one of our departments. Department. So correct this. Departments of chemistry. The subject of the day is chemistry. This contents will dedicate to pre-Form 3 or Form 3 or QT students or reciters or grade 10 and the chemists or teachers who are teaching chemistry. And we are in chapter 1 that called the chemical equations. This is session 60, which is titled as molecular or formula chemical equation. That's what I'm going to teach you today. So I wanted to insist you that I'll be using the syllabus of United Republic of Tanzania. So I'll be using chemistry syllabus for ordinary secondary education, Form 1 to Form 4, to teach these contents. It doesn't mean that because you're not a Tanzanian, these contents will not help you. That's not true. These contents will help you because, you know, the chemistry I'm going to teach you, or the chemistry that you have to cover or used to learn in Tanzania, it's a cross-cutting, it's universal chemistry that is being studied worldwide. Okay, so if it's your first time and you're a new student, I would like just to navigate with you on 5 steps for you to register yourself permanently. And it's just one-time registrations, there's no any charges, and this is what we call the registrations to also. If you've already registered yourself, just listen to these steps in order to share with other students across the country or across the continents or worldwide. The first step, if you have an email, quick, skip the first step. If you don't have, then we ask you firstly to create or open a new email. It might be a Yahoo email or a Gmail. Okay. The second step, we ask you to sign in. Use your email to sign in what? To sign in YouTube applications by using any receiving device. So it means that YouTube application installed in any electronic device. In most, it means we call it just receivers. Okay, by what? By email. So you can only sign in by using an email. If you don't have an email, you cannot sign in. How do you sign in? If you open the applications of YouTube, at the top of right hand side, you will see the buttons written sign in. So once you click, you'll be prompted to provide your password and username. The second step, we ask you to search what? Search now Tanzania Online Ordinary Secondary School. Tanzania, just search now Tanzania Online or Level Secondary School in square bracket Olenjolai. In short, you call it also. So search the also where? In YouTube. Don't search the also in Facebook at this time. Okay? So in YouTube. So when you search it, you will meet our poster, a welcoming poster for our school. And this poster it contains what? Tanzania National Flag. When I say Tanzania National Flag, means this poster contains this national flag to indicate that this is the national program. So beside it is the name of our channel, which is written Tanzania Online or Level Secondary School in square bracket Olenjolai. Don't search to also, it's not there. Search this official YouTube name. Tanzania Online O-Level Secondary School in square bracket Olenjolai. This is an abbreviation. Then you'll see also the number of videos. We thank God by His own grace, we have now published more than 100 videos. You'll see also the number of subscribers. Subscribers, these are the viewers who loved our contents and registered themselves. Within a minute, yourself also you are going to add the subscribers family. Then the first step, we ask you that you are not yet in the school. When you see this round button, we ask you to click the round button. So click the round button once, and then the YouTube software will take you into our online school. So in our online school, you will see a trailer video, and also you'll see what in horizontal toolbar, which tells us what homes, and then you have what the videos, then you have what the playlist, then we have community, we have channel, we have about. I will come later into this part. Right now, just to check that horizontal bar and skip it. Just to look the button, which in most cases is at the bottoms of the video, which returns subscribe. Subscribe. So this button has a red background and white text. So click that button once, the text will change from subscribe into subscribed, and the icon of the bell will appear. Click this icon of the bell once, you'll be prompted with 3 options. Choose the options of 40 of all. Once you're done with that, you have already registered in our Tanzania Online O-Level Secondary School in square bracket as one of our official YouTube channel. So why did you subscribe? In order for you to get notification whenever we publish any new video of training. Because we have a vision to record more than 600 videos that will be teaching you about chemistry, physics, and basic mathematics from 1, from 2, from 3, and from 4. So stay tuned. So be consistently online in order for you to receive our content, because at the name indicate there the Tanzania Online. So online means we are providing our contents online. We don't have a physical school like that. So never find a physical school like that. We are just recording our videos and then publishing, distributing them by using the internet. Then the sixth step, we like also to help you to access our contents easily. So come, it means check go at the top of the screen or of the window that you're watching right now, and then you'll see the horizontal toolbar, homes, videos, playlist. So we ask you to click the word playlist. Please follow these steps to help you to have a good focus and to access our contents systematically, rather than just spending much time on searching the particular session. So click the playlist. Then we have, as I said, that this is chapter 1, technical questions. We have created this playlist. So then after you click the playlist, you will see so many playlists. Find the playlist written chemical equation. So once you find, means you have to click it once. Then you'll see all the sessions, all the videos from the first session to the last session. So, and these sessions will be well organized systematically. So from there, if you cover, for example, if you cover session 6 right now, then it means that you have to go into session 7. So if you don't follow this technique of use the playlist, you don't know the name of the next session, or session 7. Okay, again, we know that you love our contents, and then we ask yourself, how can you share these contents to other students? So click the share, check at the bottoms on the right hand side of or at the bottoms of your video. Then you'll see the share icon. Just click that share icon to share it. To share this video link. So to share this video, link to other students. Other students via social media, for example, Facebook, WhatsApp, etc., etc. Welcome again into us. So right now, thank you for registering yourself. I want to tell you that you'll never cry for you to register yourself into also, but you'll be always giving God all your thanks. Okay, so my dear students, let us do the quick review. Let us start our programs of today, quick review. So let us do the quick review of session 5. Listen carefully. Session what? Session 5. The previous session is session 5. So this session 5, it has been titled as Wordy Chemical Equation. I've been teaching you about wordy chemical equation. Wordy chemical equation. So the first thing that we said, or I told you that a chemical equation represents a chemical change by means of symbols and what? And formulas. So it means we'll be dealing with symbols and what? And formulas. Are representations of what? Of the chemical equation. Then I told you that how many types of chemical equation we have in chemistry? 3. So you have 3 types of chemical equation. The first one is called the word chemical equation, which I taught you in session 5. I want to tell you that there is a little bit confusions of the number of the session, of the name of the session and the number. So that should not be, for example, because you know that I covered, for example, session 3 and session 4. I created it after teaching session 4. After teaching session 5. So it means that you might find some challenges in what, just in naming, but the only thing that you have to focus is how do we name and arrange. That's the way that you have to understand. Because session 1, it was just general introductions of chemical equation. Session 2, it was types of chemical reaction. Session 3, it was techniques of completing incomplete chemical equations. Then session 4, it is also completing incomplete chemical equations. And session 5, it was word chemical equation. So the first type is word chemical equation. The second type is what we are going to teach you today. It's molecular or formula chemical equation. Molecular or chemical or formula chemical equation. Then the third type I mentioned to you, it is ionic chemical equation. So if you do remember that the general form of what? Form of any chemical equation, okay, any chemical equation is what? Is on this side we have reactants. We have one or more than one reactants. Okay, reactants, and then save an arrow, and here we have what? Either condition or what? Or catalyst. Condition or catalyst. And hence on this side we have what? Products. Either one product or more than one products. So in case of the wordy chemical equation, right? So wordy chemical equation, for the wordy chemical equation, this is an equation in which reactants, so the name of reactant or reactants is written in words, not by using the molecular form. So then we have this one. So even also we have condition, as I said, we have catalyst. Then so on this side we have product. It will be either a single product or more than one products. So this product also, the names of products, whether compound or element, is also written in word. So just to remind you, example, we can have a reaction between magnesium plus oxygen. So this is the reactant side. So after the reactions take place, hence the new compound will be formed as what? Magnesium oxide. So you see that the name of magnesium is used weight, and here also we use the weight. So even the product also used the weight instead of 40 molecular formula. So that's what we have been covering, or we've covered in session 5. In case you missed it, you can access session 5. It's called Wordy Chemical Equation in our official YouTube channel at this moment. So ladies and gentlemen, let us continue with our today's session. I have so many informations to share with you today which can transform you. So simply let us start with introductions of what? Of the concept that I'm teaching, this molecular, say with me, molecular chemical or formula equation. Chemical equation. Molecular chemical equation. So introductions of molecular chemical equation. So before we define or we answer the question, what is molecular chemical equation? Let me just give you this brief introduction. A chemical equation, bear with me, a chemical equation. A chemical equation represents, any chemical equation represents what? Chemical change. We have physical and chemical change. But then chemical change, this chemical change is presented by means of what? By means of symbols. By means of symbols and formula. So symbols and formula. When you say symbols, we mean about molecular formula. When you say formula, it can be either Wade chemical equation or molecular chemical equation. Again, just to remind you, there are three types of So in chemistry, there are three types of the chemical equation. There are three types of chemical equation. Namely, the first one is called the Wade chemical equation. Wade chemical equation. The second one, it's the one that I'm teaching you. It's called the molecular or formula chemical equation. And the third one is called the ionic chemical equation. Ionic chemical equation. Say with me, ionic chemical equation. So we'll be focusing, so we have covered this in session 5. So today I'm going to cover this, and the next sessions we are going to cover ionic equation. But before ionic equations, we have to teach about balancing the molecular chemical formula, then we'll teach about the ionic chemical equation. So you have to stay tuned. Everything will come to you at any time and anywhere. So you can pause the video and then copy these steps for you to register yourself, and then afterwards, so I can clean the blackboard and write important information. Do it right now. Okay, so we have a fundamental question here while you are, just to give you a minute to copy, we have a fundamental question here. This is question 1, okay? This is fundamental question for Olenjolai. What is molecular formula? What is molecular or formula chemical equation? What is it? What is molecular or formula chemical equation? That's the question we have on the spot. You can pause the video and try to answer. It's not a difficult question. We've been studying about science, which is kind of chemistry, since we are in primary education. Okay, so there are so many definitions of defining this term, but I will be teaching you 2 fundamental definitions. So the answer for that question, molecular, say with me, molecular chemical equation or formula chemical equation is the type of chemical equation type of chemical equation that is written by using molecular formula of chemical substances. That is the first definition. What is molecular chemical equation? Is the type. So this is just, you have to print this. So is the type of chemical equation that is written by using molecular formula of chemical substance. So the only thing, it's written by using molecular formula of chemical substances. What are these chemical substances? We mean reactants and what? And the products. Chemical substances involved in the chemical reactions. Chemical substances or elements means chemical substances or elements involved in the chemical reaction. That's the meaning of what? Of molecular formula. So molecular formula again, molecular chemical equation is a type of chemical equation that is written by using molecular formula of chemical substances or elements involved in the chemical reaction. How many basic types of reactions I have taught you in this topic? I've taught you 5 types of reaction. This is the one way of defining. We have another way of defining the word molecular chemical equation. So this is the response. So molecular chemical equation is an equation in which formulas, plural, of the compounds are written. As through all substances existing as molecule. As molecule. So molecular chemical equation is an equation in which formulas of the compounds are written through all substances existing as as molecules. Molecular chemical equation is an equation in which formulas, the chemical formulas of the compounds are written through all substances existing as molecules. Okay, so this should not, you can choose either. I think that I recommend the first definition. So then we say that from the general chemical equation, which actually that I have been teaching you, I've been teaching you. So from the general chemical, from the general form of chemical, from the general form of the chemical equation. So do you remember the general form? General form of the chemical equations or general form of the chemical reaction? Yes, if you forgot, I mentioned in the quick review of this session. And in previous sessions, I've been using it in different parts of the session. So the general form of the chemical equation is this. So is this reactants on the left-hand side? We have what? We have either single reactant or more than one reactants. And when reactants react, maybe under the presence or without the presence of the condition, or under the presence or without the conditions of the catalyst. So it depends on the types of reaction. On the left-hand side, we are going to represent product or products that will be formed. So remember that previously, in wet chemical equation, the reactants of the elements or reacting substances and the products of the chemical reactions are written in wet. So it means that in molecular chemical equation, reactants will be written by using the molecule. It means that the molecule, or it means the molecular formula of element or compound, molecular formula. And even also product will be written in what? In molecular formula. Right? So all reactants will be written in molecular formula. All products of molecular chemical equation will be written in what? Be written by using the molecular formula of what? Of compounds. For example, if we have reactant A react with reactant B to form a new compound, maybe called C. So it means that this one, we write it in its molecular formula. And this one also, we write in its molecular formula. This one also, we write in its molecular formula. At the meaning. Okay? So, definition of terms. Let me teach you a definition of terms used in general chemical equation. Okay? You remember the general chemical equation? Yeah, so it means that from here we have reactant. Suppose that we have more than one reactants. We have condition or catalyst, and then we have what? Product or products. For example, suppose that here we have A plus B, then we have an arrow. Then you have maybe form a new compound, C plus what? D. What does this plus sign mean? What does this arrow mean? And what does this plus sign mean? That's what I want to teach you, because I want you to understand, not just writing chemical equations by using a inverse notation, but you don't understand why are we using those signs. Okay? So you say that the symbol, so suppose that this is we call the left hand side. This is in short called the right hand side of the chemical equation. So the first definition is that the symbol, we have used a symbol for symbol of plus. The plus sign on the left hand side of, okay, so suppose that this is reaction 1, this is reaction 2 of reaction of equation what? Equation 2. So the plus sign of equation 2 above means what? Means react. So A reacts. So react or reacts. Reacts with so it means that when we write A plus B, in other words, A, so this plus sign, this one, indicating what? React with. So A reacting with B. What do you mean? A react with what? A reacting with B. And the first symbol. Second symbol. Definitions of terms or what? Terms or symbols. Terms or symbols. Then you have the second symbol. The second symbol is that the symbol, the arrow, come into the next symbol, this one. The arrow in the chemical equation, the arrow in the chemical equation means what? Means to form. Means to form. So the arrow means to form. What does it mean? Listen carefully, because I want you to understand. You are in the home of understanding. For example, reactant A reacts with reactant B, then this arrow means to form. So plus means what? Reacting with. So A reacts with. Arrow means what? Arrow means to form. Form what? Product. That I mean. That's what we mean in chemistry. Very simple. The symbol of plus sign on right hand side of the general of the chemical equation, of the any chemical equation, means what? ND, so means end. Means end. So the plus sign on the right hand side, whether one plus sign or two addition signs or three addition signs, means end. So what does it mean? For example, from our general equation or our example, reactant A reacts with reactant B to form what? Product C and D, product D. So this plus sign means what? Reacting with. Okay? This means what? To form. This means what? ND. Regardless that you've used it, maybe one symbol in the chemical equations, or you've used the two symbol on the right hand side or two symbol on the left hand side, they still have the same meaning. Okay, in case you have any question about session 6, please don't hesitate to ask it in the comment section of this video. Where is comment sections? Below there. So comment sections is downstairs. So down there. Ask your question, give us feedback, whether you understand or you don't understand. So you should not worry or should not be fearful on learning molecular chemical equation, because this is the foundation concept of entire chemistry. Okay, so it's a central concept, in other words. Okay, so let us check requirements of molecular chemical equation. Before I give you examples, I still have 2 concepts to teach you. Requirements of molecular chemical equation, or requirements of molecular equation. The word chemical may be included or excluded. Sorry, not the question. Requirements of what? Of creating a molecular chemical equation. So let me start with this sentence. To write a correct molecular chemical equation. To write a correct molecular chemical equation, the following are the basic requirements. So to write a correct molecular chemical equation, in order to write a correct molecular chemical equation, you have to know the following basic requirements. So in order to write a correct molecular chemical equation, we say that you need the following basic requirements. Basic requirement. Basic requirements. Okay. You need to know. You need to know and follow the following basic requirements. The first basic requirement is this: the knowledge of the chemical symbol of elements and compounds involved in the chemical reaction. You should have, or you must have, knowledge so you must have knowledge of chemical symbol of chemical symbol of elements and compounds. Of elements and the compound. You must have knowledge of chemical symbol of each element or elements and compounds. That's the first requirement. For example, should know the symbol of magnesium is this. Should know the symbol of chlorine as molecule is this one. Should know the symbol of what? Of potassium is this. Should know the symbol of carbonate is this one. Should know the symbol of sulfate. Okay? Maybe the symbol of what? Of nitrate. Nitric acid. Maybe the symbol should know the symbol of hydrochloric acid. Should know the symbol of what? Silver chloride, etc., etc. So you need to know the knowledge of different symbols or chemical symbols of the elements or compounds that might be used in a particular or in representing or in writing a particular chemical equation. Okay? That's the first step, or that's the first requirement. The second requirement, just to mention, because I'm going to teach you within a few minutes. The second one said that consider the physical state of each reactant. Say physical state. Hopefully, you have never learned about physical state. About 3 physical states that you are using in writing molecular chemical equation. So consider physical state of each reactant. Excuse me. Each reactant in dot and product. Consider the physical state of each reactant and the product. Yes, and product. So you should know. If, for example, I mention sodium hydroxide, for example, if I mention sodium hydroxide, in most cases you find that it's just well defined by using the symbols rather than what we have there. So that's the second requirement. Second requirement. Involve the necessary condition condition or catalyst, involve the necessary conditions or catalyst. Involve the necessary conditions or catalyst required for the chemical reaction to take place. Chemical reaction to take place. Okay, excuse me. Let me finish the first step, then I will explain to you. Let me explain you the 3 steps first. Then I will finish with the first requirements. These are the requirements. So the subtitle of this part is called Requirements of Molecular Chemical Equation. In order to write a correct molecular chemical equation, you need to know the following basic requirements. The first basic requirement, you must have knowledge of what chemical symbols, or you must know the chemical symbols of each element and compounds. So if you mention it is silver chloride, then you know the symbol silver chloride. It's nitric acid, you know it's a symbol. It's magnesium, you know it's a symbol. All right? Okay? That is the meaning of what the secondary requirement. The second requirement is to consider the physical state of each reactant and products. I will teach you. What does it mean to consider? It means that if it will be given to complete molecular chemical equation, you will find that the physical states are given. Okay? So that is what you have to make sure that you understand and keep moving. The second requirement is we say consider the physical state of each reactant and product. We have only 4 physical states in chemistry that I will teach you today. So stay tuned. The first another requirement when you're writing the molecular chemical equation also, we may end with having a balanced chemical equation. While in chemistry, it should be balanced. Balance the number of moles let us balance the number of moles on both sides of reactant and product. Balance the number of moles of reactants and what? And the products. Reactant and product. So balance the number of moles on both sides of reactants and product side of the chemical equation. Balance the number of moles of reactant and product. Involved in the chemical equation. Okay? So balance the number of moles of reactant and the number of moles of product involved in the chemical equation. This will be the last requirements whenever we are writing any molecular chemical equation. So you have to make sure that we follow that first requirement. So again, I'll let teach you about physical states of the chemical reaction. So you can take a course, and then after physical state, then I'll give you 10 examples, then we'll solve the question, and then we'll end our today's session. Okay? Do you enjoy what am I teaching you? Please tell me in the comment section whether you have understood. Okay? Okay, so before we go into the concepts of the physical state of the elements or compounds or of the reactants and product, let me repeat it just these 4 requirements because it's very important and you have to remember. The first requirement, in case you want to write a correct molecular chemical equation, you should know the chemical symbols of elements, of each element, right? Of the each elements or compounds used in the chemical equation. For example, this is symbol for magnesium, symbol for chlorine molecule. This is symbol for potassium, symbol for carbonate. This is what is symbol for nitric acid, symbol for hydrochloric acid. and symbol for silver chloride. The second step, you have to consider the physical state of each reactant and what? And each reactant and product, which will teach you right now. The third step, or the third requirement, you have to involve the necessary conditions or catalysts required for the chemical reaction to take place. And the fourth requirements, you have to balance the number of moles of reactant and product involved in the chemical equation. So right now, let me teach you the next concept before I give you 10 examples of molecular chemical equation. And this concept, ladies and gentlemen, if you have any question, don't hesitate to ask in the comment section. We call them physical states. So these are physical states of chemical reaction. Physical states of chemical reactions. Physical state of chemical reactions, which is the second requirement of writing a correct molecular chemical equation. The fundamental question of Olenjolai whenever introduce you a new terminology is, what is physical state? What is physical state first? Because you want to study it while you don't know what is it. What is physical state of the chemical reaction? Of the chemical reaction. What's the meaning of the physical state of the chemical reaction? Okay, so this is the definition. Physical state is a form of matter. Is a form of matter. So the form of matter in which a compound or element existing, during the chemical reaction. So physical state is the form of matter. It's a form of what? It's a form of matter in which a compound or element exists. So in which the compound or element exists during the chemical reaction. For example, if now I want to react or I want to destroy this exercise book, so what will be my physical state? A solid state, right? So that is my physical state during the times that I want to destroy the exercise book. So physical state, ladies and gentlemen, it is a form of matter in which a compound or element existed during the chemical equation, during the chemical reaction. Okay? But the simple definition of physical state, if you've been asking yourself such kind of the question. So you say in chemistry, there are only four physical states of elements or compounds. There are only four physical states of element or compound used in the chemical reaction. So in chemistry, we have how many physical states? 4. How many types of matter do we have? 3. Solid state, liquid state. Okay, no. How many types of matter? We have solid matter, liquid matter, and gaseous matter. But how many types of physical state do we have in chemistry? 4. We have solid state, we have liquid state, we have aqueous state, we have gaseous state. Okay? So use it in the chemical reaction. In the chemical reaction. So each physical state each physical state has its symbol, used in the chemical reaction. So I want to mention the 4 physical states of the chemical, the 4 physical states that we have in chemistry. But I want to include the symbols that we are using when we are writing a molecular chemical equation. So I don't want to mention, but I want also to show you the symbols that we are using. So this is simple explanation, should not bother yourself. In chemistry, there are only 4 physical states of elements or compounds used in the chemical reaction. Each physical state has its symbol used in the chemical reaction. Okay, so these are those physical states. Okay, it means that the four physical states, and they are corresponding symbols. The first one is solid state. The solid state, when you're writing a molecular equation, we use a small or a lowercase s as a subscript of that element or compound used in the chemical reaction. The second physical state is liquid. So liquid, its symbol is L. So you can find maybe the physical state of first reactant is liquid, the second reactant is solid. So we'll be interchanging, we'll be using this information in different aspects of chemistry. Then you have what? Gaseous. So gaseous state. This gaseous state, we use the lowercase g. So you can see that when we've been writing or we've been teaching you about this chemical equation, we were not involved in the physical state because we are avoiding confusion. Then we have also the phosphor. This is called aqueous. Say aqueous. So this is the symbol for aqueous. AQ. So these are the 4 physical states and their symbols that we're using in writing chemical equations. Should not worry, should not bother, but you have to know the standards. The first physical state is solid. When we're having metals reacting with non-metal, you find such kind of the strength of the bond. Then the second one is called liquid. The third one is called the gaseous. And the fourth one is called aqueous. There's a difference between aqueous state and the liquid state. You have to note that. Okay. So let us write. So after teaching you about molecular chemical formula for a while, let me present to you 10 examples of molecular chemical equations. 10 examples. 10 examples of molecular chemical equation. With these 10 examples, you'll understand the concept and enjoy it. 10 examples of molecular chemical equation. Remember that we can write any word, any form, any word chemical equation so we can write any word chemical equation in molecular chemical equation. So you can write any word chemical equation. So means if you'll be given a word chemical equation, we can write it in molecular chemical equation. What does this sentence mean, for example? Because I feel in my heart that some students didn't understand here. Example. So you have a reaction between sodium, okay? So sodium react with what? React with chlorine, form what? From sodium chloride. From sodium chloride. So this is word chemical equation. So in molecular form, we say that what the symbol for sodium? It's Na. Plus, what the symbol for chlorine? But remember, chlorine exists here as gas. What the symbol for chlorine? So sodium plus what? Plus chlorine molecule. What will be the product? Sodium combined with chlorine to form sodium chloride. From sodium what? Sodium chloride. So you have two ways of balancing this equation. Because the issue here is the issue of chlorine. The first way is just to reduce this sodium chloride, this chlorine into one. But it has been. So it means that the technique, you can put a half, so that half gas of these two, and everything will be okay. So sodium reacts with chlorine to form sodium chloride. So then the next step you have to balance. sodium plus chlorine gives what? Sodium chloride. So we can add 2 here, add 2 here. 2 atoms of sodium, 2 atoms of sodium. 2 atoms of chlorine, 2 atoms of chlorine. We are done. Also, we can change, means that we can write any molecular chemical equation in what? So we say that, and vice versa. And vice versa. So the following are the 10 examples. Of molecular chemical equation. Following are the 10 examples of molecular chemical equation. The first one, it's combination reaction. We have reaction between magnesium and oxygen, but oxygen, I remember magnesium, so now we start to include the physical state. Magnesium exists in solid physical state, oxygen exists in gaseous physical state. So when magnesium reacts with oxygen, the product will be magnesium oxide. So what will be the physical state of the oxide? This will be what? Aqueous, it's not in solid. Okay? So is equation balanced? No. We have 1 atom of magnesium, 1 atom of magnesium. We have 2 atoms of oxygen, but 1 atom of oxygen. So the best technique, we have to add 2 here. So now we have 2 atoms of oxygen. But here, when we have been balancing the number of oxygen, we established the balance between magnesium and magnesium. So here we have 2 atoms of magnesium, here we have single atoms of magnesium. So it will use 2. Okay? So that's the first example. That's the way that we used to write some examples of what? Molecular formula, molecular chemical equation. The second reaction is displacement reaction. Say displacement reaction. Magnesium into solid state plus what? Plus copper sulfate. And this copper sulfate is in aqueous state. So remember that, how do we form a product? How do we form product? So magnesium is going to displace what? Copper. And magnesium combined with sulfate to form a new compound, while copper exists as metal. So after this displacement reaction takes place, magnesium sulfate plus what? Plus copper. Then next, before you go to the next stage, you have to make sure that okay, so here this is solid state, magnesium sulfate. This is solution, so it is in the aqueous state. So that's the second example of molecular formula. So as we said that you should have the knowledge of different chemical symbols. Okay, so magnesium, when magnesium reacts with copper sulfate, the product is magnesium sulfate plus copper. So an example. I'll give you at least one example in each type of chemical reaction. So right now we have a salt called calcium carbonate, and this calcium carbonate undergo heating. So it means that the calcium carbonate decomposes. When calcium carbonate decomposes, we get calcium oxide. Calcium oxide. Okay, so we have calcium oxide plus carbon dioxide. This calcium carbonate I'm not sure whether it exists in form of salt, but this one is gaseous, and this one is gaseous. Okay? No. This is in the aqueous state. This is, in most cases, the solid state. So these are the reactants of which type of this chemical equation is what? Decomposition reaction. This one, which type of it? Displacement reaction. This one, combination reaction. Okay? Then the first example, we have sodium plus chlorine. Okay, let me budget the space. The first example is the reaction between sodium chloride react with what? When sodium chloride react with silver nitrate. So how is this reaction take place? Sodium chloride is salt, silver nitrate is salt. So silver will displace what? Sodium, right? And react with what is chlorine to form what? Silver chloride. And also sodium will displace what is silver. Okay, so simply say that silver will react with chlorine. And here mean that here, so that the sodium react with nitrate. Okay? So sodium reacts with nitrate to form sodium what? From sodium nitrate. So silver reacts with chlorine to form silver chloride, then sodium reacts with nitrate to form sodium nitrate. This is just a solution, it's rough. Okay, it's rough. So this is just the solution. So now the product will be what? Will be sodium nitrate plus what? Silver chloride. The equation has been balanced. Why? We have one atom of sodium, one atom of sodium, one atom of chlorine, one atom of chlorine, one atom of silver, one atom of silver, one atom of nitrogen, one atom of nitrogen, 3 atoms of oxygen, 3 atoms of oxygen. So it's balanced. The first example of molecular chemical equation is neutralization reaction. When sodium hydroxide react with hydrochloric acid, all of these are in aqueous. So remember that this is aqueous, and this is aqueous. Okay, and this is also aqueous. I'm not sure about that. Maybe it is formed with precipitate. So sodium hydroxide reacts with hydrochloric acid from sodium chloride. From sodium chloride plus what? Plus what? Is the equation balanced? Yes. No. Why it's not balanced? Here you have number of sodium balanced, number of oxygen. So it's balanced, number of hydrogen. Yes, it's balanced also. We have 2 hydrogen atoms, we have 2 hydrogen atoms. Then 1 atom of chlorine, 1 atom of chlorine, so it is balanced. This is neutralization reaction. Example 6. Say that you have calcium, calcium hydroxide plus sulfuric acid. So the calcium hydroxide, this is in aqueous state, and this one also, it is in aqueous state. So calcium hydroxide reacts with sulfuric acid. Calcium will combine with sulfate from calcium sulfate. Hydrogen will combine with hydroxide to form what? Water. So the products for this case are calcium sulfate, okay, which will be in aqueous state also, plus what? Plus water. And this is always in liquid state. Is the question balanced? Yes. No. Here you have 2 oxygen atoms, then you have 6 oxygen atoms. While on this side, we have only 5 oxygen atoms, similar to hydrogen. Hydrogen, we have 4 hydrogen atoms, 2 hydrogen atoms. So the best way to balance just into these 2. Okay. So now you find that the number of oxygen here we had 60, and here also you have 6. The number of hydrogen here you have got 4. So 4 hydrogen atoms and 4 hydrogen atoms. 2 oxygen. Okay. We discussed about that. The 7th example. Potassium. What we get if we take potassium solid state plus chlorine in aqueous state. Potassium plus chlorine in aqueous state. This will form what? Potassium chloride. And this is in aqueous state. Okay. So, should we balance? Yes. So here we have 2, and here we introduce 2. 2 atoms of potassium, still have 2 atoms of potassium. 2 atoms of chlorine, 2 atoms of chlorine. That's all. And the physical state, that's how we write the molecular formula. The 8th example. calcium plus silver sulfate. Calcium plus silver sulfate. Calcium plus silver sulfate. What do we get? This is in solid state. So this is displacement reaction. Okay? Displacement reaction. Calcium. So displacement reaction, because this calcium is going to displace silver and combine with sulfate to form calcium sulfate plus silver itself. So we have calcium sulfate plus silver. The ninth example. So this is in aqueous state. This is solid state. So when when silver sulfate reacts with calcium, the products are calcium sulfate plus what? Plus silver. Then the ninth example is when we take potassium carbonate, decomposes potassium carbonate under the presence of heat. So potassium carbonate, when it decomposes, form potassium oxide plus carbon dioxide. Okay, potassium carbonate decomposes from potassium oxide, and then we have 40 carbon dioxide. So potassium carbonate decomposes to form potassium oxide, which is in aqueous state, plus what? Carbon dioxide. So that the gaseous state, aqueous state, and possible that this is in solid state. Not sure, but I will give you the information later. I'm about to give you the homework. Sample 10. What do you get if you take sodium hydroxide, react with nitric acid? So sodium hydroxide plus nitric acid, this will form what? Sodium nitrate plus what? Plus water. Sodium hydroxide plus nitric acid will form what? Sodium nitrate plus water. My dear student, those are 10 examples of molecular chemical equation. So let me put the question there. Now it's time for problem solving. me check the end of the previous. Oh, this is liquid. So aqua state, aqueous, or sometimes will be solid. Then we get it liquid. Example 6, example 8. So this is example 9. I'm looking at the number for example. So this is example 9. Example 9. Complete. So the example 9 refer a book called the Chemistry Forms 1 and 2, Form 3 and 4. Students' book. This one. Made already. So the question refer secondary, basically. Secondary. Refer the book, we call it secondary. The book is called not the second, it's called the Chemistry. Chemistry, for chemistry forms 3 and 4 by time. Chemistry forms 3 and 4 by TANZANIA Institute of Education. These are the questions, the ending at the end. Complete and balance. Complete and balance the following questions. Complete and balance the following equations. A, zinc plus zinc chloride, zinc plus chloride. This is gaseous state. Then you have to give product and balance. So this is displacement. Now this is the combination reaction. So the product will be zinc chloride. equation is balanced. B. What do you get if you take a copper solid state plus oxygen? So copper plus oxygen, this will form what? Copper 2 oxide. So copper plus oxygen form copper. So this is aqueous and this is aqueous. Then C. Magnesium plus oxygen. This will form what? Magnesium oxide. This is in solid state. This is in gaseous state. This is aqueous. So let me give you the quiz that you have to try. In case you have any question about molecular chemical equation, don't hesitate to ask other students and ask me in the comment section, please. Because you might find that if you don't care, then you find that because you have not been serious, that's why that you fail to get the right answer. So Roman B is the question that I took from the end of chapter questions. So D, we have P. First of all, to identify what this means, and then you have what? Oxygen, form of gas. So phosphorus plus what? Oxygen. This will form what? So complete. So it is what? So a quiz. So that the quiz. So phosphorus reacting with oxygen, what will be the product? Pause the video and try on the rough paper. Thank you. So this one, the compounds will be phosphorus. So it means that phosphorus trioxide. So here we have what? We balance. To balance, you have what? So here it is 3, we have 6 oxygen. Here it is 2, we have 2, we have 6 oxygen. So here we have 2 atoms of phosphorus, 2 atoms of phosphorus, 6 atoms of oxygen, 6 atoms of oxygen. Ladies and gentlemen, the homework that you have to do today is to review every concept that I've taught you in molecular formula, or in molecular chemical equation. Ladies and gentlemen, this is the end of this fantastic session. I invite you to join me in the next session, which will be session 7, when I'll teach you about another concept. Make sure that you review these concepts of molecular or formula chemical equation, because it is what we use even in the next concepts, as long as you continue with your studies. So I thank God who have created me in his own image and likeness, and I thank God who have built the gift of teaching and gave me instructions just to take care of people's vision. So I would like to invite you that keep enjoying what you have created, keep enjoying about molecular chemical equation, get prepared to start a new session. Make sure that you don't miss. Remember to register, like our video, read the descriptions, ask questions in the comment section, so that we can keep moving as well as God gives us opportunity to make it. Okay, so before we end this session, so let's go pray in order to thank God for this session. So let us pray within a minute. Our Father in heaven, we come before your presence. We say thank you for your greatness. Thank you because you're wonderful, you're grateful, Father. We give you all the praise and all the honor. We thank you, Lord. Father, we come before your presence, still have the program. In the name of Jesus Christ, Father, that need your presence, we welcome you to give us strength, to give us instruction, to do greater things. Our Father, thank you for your greatness and thank you for this session 8, session 6 of what? Of molecular or formula chemical equation. Our Father is in heaven, we put this concept in your hands so that make sure, Father, that you do miracles and you do great things to your people. In the name of Jesus Christ, amen. So, may God bless you. Keep enjoying the beauty of chemistry. Let us meet in the next session. Stay tuned and be blessed.
Ibariki Tanzania, dumisha uhuru na umoja, wake kwa waume na watoto. Mungu ibariki Tanzania na watu wake. Ibariki Tanzania, ibariki Tanzania, tubariki.